Today we're going to start our review of the law of sines. Remember, the law of sines uses three particular types of triangles: angle, angle, side, angle, and side, side, angle. We're going to do angle, angle, side, and angle, side, angle today. Now, the law of sines is important and helpful when you are trying to find a missing angle or a missing side in a triangle, but it's not necessarily a 90-degree triangle. If it was a 90-degree triangle, we could use our sine rules. We could use our trig functions. We could use Pythagorean theorem. However, when you don't have a 90-degree triangle, we have to have another way, and that's where the law of sines and cosines comes in. First thing we want to do is we want to remember how to discover if a triangle is angle, angle, side. And it has to be consecutive in that order: angle, angle, side. Look at this first triangle. Notice we have two angles that are given. We could find this third one if we wanted to, but it's not necessary. But if you look at it, we have angle, angle, then followed by a side. Notice the side is not in between the two angles. So it's consecutive, it flows. Angle, angle, side. Same thing with this one, but in the opposite direction. Angle, angle, side. Look at this one. Angle, angle, side. Okay, so all three of these triangles would be an example of angle, angle, side. Now, the next one is going to be angle, side, angle. When you have angle, side, angle, the side has got to be on the same with the two angles you're given. So, angle, side, angle. Look right here. Angle, side, angle. The two angles that you are given share this common side. That's what makes it angle, side, angle. Same thing here. Angle, side, angle. Okay, so let's get out our worksheet and let's look over some problems using the law of sines. Well, what is the law of sines? Remember, it's the sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Look at my triangle right here. Let's remember how they're set up. If you've got angle A, B, and C, side A will be directly across from angle A. Side B will be directly across from angle B. And side C will be directly across from angle C. So what we're going to practice on and work on today is angle, angle, side, and angle, side, angle, because those two particular triangles, when you use the law of sines, they only have one particular solution. Remember, side, side, angle is the triangle that has ambiguous cases. So we'll go over those tomorrow. Now, let's look at this first triangle. Okay, let's figure out what we got. Do we have angle, angle, side, or do we have angle, side, angle? We're looking for X, but look at what we're given. We've got 34 degrees, 52 degrees, and a side that's 10. If this was angle, side, angle, the 10 would have to be right here. But this is actually angle, angle, side. So when you have angle, angle, side, you can use the law of sines, sorry. So let's set it up. Since we're looking for X, we see that X is across from our 52 degrees right here. And then we have 10, which is across from our 34 degrees right here. So let's set up our ratio, okay? We're only going to need two of them. So let it be A, B, C, whatever you want to do. So in order to find this one, I'm going to take what I have, which is 34 degrees, the sine of 34 degrees over the side that goes with it, which is 10, is equal to the sine of 52 degrees over its side, which is X, because that's what I'm looking for in this particular problem. Do you notice that you created a proportion? When you solve a proportion, remember, just multiply in the diagonal. X times the sine of 34 degrees is equal to 10 times the sine of 52 degrees. To solve for X, we'll simply divide both sides by the sine of 34 degrees. This whole thing, sine of 34 degrees. Okay, so these two, of course, will cancel out to 1, leaving me with X. And then, to get this particular solution, I'm just going to plug this whole thing into my calculator. 10 times the sine of 52 degrees all over the sine of 34 degrees. If you're using your graphing calculator, make sure it's in degree mode because you're dealing with degrees and not radians. If you plug this into your calculator, you're going to get a fairly long decimal. But our directions here tell us to round all answers to the nearest tenth. So when you plug this in and you round it to the nearest tenth, you'll end up with 14 and 1/10. So that wasn't so bad, was it? Now if I wanted to find my other side here, I could do the same thing. I can do 180 minus 52 minus 34 and get this value. And then I can set up my proportion, sine of 34 over 10, and then equals sine of whatever this is over x. And I can figure out what my third side is as well, because I cannot use the Pythagorean theorem here because this is not a 90-degree angle. Okay, let's look at number 2. Okay, let's figure out what we got. Do we have angle, angle, side, or do we have angle, side, angle? Okay, so looking at this one, once again, it looks like we have angle, angle, side. So let's go ahead and figure out what we got. We're looking for x. It's across from 119 degrees. We are given side length 7. It's directly across from my 21 degrees. So let's do the sine of 21 degrees over, well, what's across from that? 7. And that's going to equal the sine of 119 degrees. And that's going to be across from x. So do your thing, find your cross product. We'll have x times the sine of 21 degrees is going to be equal to 7 times the sine of 119 degrees. Divide by the sine of 21 degrees and the sine of 21 degrees. That, of course, is going to give you a 1, so that'll be 1x. Now this right here, plug the whole shebang into your calculator. And when you do, it's going to give you a decimal, but since we're rounding to the nearest tenth, we'll have 17.1 or 17 and 1/10. Okay, so what I want you to do is I want you to take the rest of this worksheet, which is only 4 more problems, and I want you to do 3, 4, 5, and 6. Okay, and then once you finish 3, 4, 5, and 6, email me your solutions. We'll go over it, and then we'll do the ambiguous cases tomorrow, which is going to be a whole lot more work for us. So y'all have a great day.